Hello everyone, this is Prashant. In this video, we are going to discuss on the topic standard test signals in the control system. Okay, so in the previous video, we discussed about the basics of time response analysis. Basics of time response analysis. So there we have seen the response of the system C of t in terms of transient system Ct of t plus steady state system. It has been divided into two parts. One is the transient part, another one is the steady state part. So where in the transient part it will be died out when t time greater than 0, and so the steady state part remains in the control system for time greater than 0. Okay, so today we'll see the standard test signals in the control system. Okay, the first signal is step input, second one is the ramp input, third is the parabolic input, and fourth one is the impulse input. Okay, so the previous video we discussed up to the ramp input. So briefly we'll go through all those test signals. One is the step input. It can be represented as r of t equals to u of t. So it will be there when t is greater than 0. It will be 0 when t is less than 0. Okay, so mathematically it can be represented as r of t equals to u of t. So once you apply the Laplace transform of this signal, r of s equals to u 1 by s. This is all about the step input. The ramp input it's continuously changes with respect to the time. So there the input is represented as r of t equals to a into t, where a is the magnitude of the ramp signal. Okay, so it will be there when t is greater than 0. So ramp signal will be 0 when t is less than 0. The Laplace, once you take the Laplace transform of this signal, r of s equals to, it will be a by s square. So these are the things we have seen in the previous, we covered in the previous video. So today let us start with the parabolic input. Third type of test signal in the control system, that is parabolic input. Okay, so parabolic input is a function that represents a signal that is one order faster than the ramp signal. Okay, so mathematically it can be represented as r of t equals to, it's a t square by 2, and the equivalent waveform for this is, it will be like this. So y-axis indicates the magnitude of the ramp signal and x-axis indicates the time period of the ramp signal. Okay, so r of t equals to, it will be a t square by 2. So one order faster than the ramp signal. So it will be there when t is greater than 0. So r of t will be 0 when t is less than 0. Okay, so this is the mathematical representation of the ramp signal and its equivalent waveform. So once you take the Laplace transform of this signal, r of s equals to, it will be a by s cube. The third type of test signal in the control system. The last one is the impulse signal. Last one is impulse signal or impulse input. So it will be represented as the xy coordinate plane. It has 0 everywhere. It has 0 everywhere, and except t equals to 0, it has infinite value. So as you see in the previous case, the step input, ramp input and parabolic inputs, it will be there when t is greater than 0, and the signal will be 0 when t is less than 0. In case of unit impulse system, it is defined as a signal which has 0 everywhere and except at t equals to 0. At t equals to 0, it will be infinite. Okay, so mathematically it can be represented as delta of t equals to integration of minus sigma 2 plus sigma delta of t equals to 1. Okay, delta of t into dt equals to 1. So always the derivative of the step function will result in the ramp function. Okay, this is also one type of signal which can be applied to first order or second order system. So these are the 4 test signals we have in the control system. So when these 4 test signals are applied to a system, applied to any system, we need to analyze the response of the system. This R of t and C of t. Input is represented as R of t and output is represented as C of t. So when these kind of signals are applied to any type of system, first order or second order system, then we can analyze the response of the system for different time intervals. Okay, thank you.